Hi everyone, Ed Tom, Product Manager with Yaskawa America, and thank you for joining this presentation on BACnet 101, an introduction to BACnet, sponsored by BACnet International. I'm sorry I'm not able to present this to you live and in person, but I'm hoping that the material that I have is going to be just as good in this presentation as it would have been if you caught me live at AHR Expo 2022 in Vegas. Now, for the following presentation, the objectives that we're going to have is that we want you to be able to finish watching this presentation and then be able to explain the purpose of the BACnet protocol. Not going to say verbatim, but at least have a very good idea of it. But I also want, as we go through this, also want you to be able to list out 5 benefits of the BACnet protocol and also 5 uses of the BACnet protocol. Don't worry, there's not going to be a pop quiz after this, but it's something to help you think about how BACnet can be incorporated or how BACnet can be used in your system or how your customers can possibly use that. So our agenda is going to be broken down into what is BACnet and why BACnet, why use that, how does BACnet work, and what else do you need to know? So starting off with what is BACnet? What is that exactly? Well, what I'm going to tell you first and foremost is that it's an acronym. It stands for Building Automation Control Network. But what does that really mean? What that breaks down to is considered an open communication protocol. So I'm going to break down each portion of it backwards, starting with protocol. So protocol is a set of rules or procedure, ultimately telling us how to do something, how to do it repeatably. Now, communication is just a method of exchanging information. So just communication protocol alone, putting those two together, you now have a method of exchanging information with a set of rules on how to do it so that it's repeatable. And the last portion of it is open. And the open is important because that means that it's available to everyone. So regardless of who you are, what you're doing, if you want to implement BACnet into your system or into your product or device, or even use it, you have a protocol that it's available to you without being locked down to one particular vendor. And we'll get into that. And I'll show something to show that it's not just locked in. A lot of vendors can implement BACnet and have implemented BACnet. So with this basic definition in mind, why BACnet? Why do we want to use that? Why do we even want to consider BACnet? Well, if I walked into the room and I said hello, and and being that this is going to be Vegas, I'm going to assume that a lot of people are going to be able to go, yeah, no problem. I understood what he said. He just greeted me. But what if I walked into the room and said hola, or someone said that back to you? Well, if you've got a good handle of the Spanish language, you might know that they were greeting you as well, saying hi to you. But you have to know that. You would have to know that portion of it. Now, let's take it a step further. What if I said ni hao? Now we might be scratching our heads a little bit. Now you might be going, okay, I know it's a particular language, but someone responds, now they respond back with konnichiwa. Hmm, now we're kind of in a situation of we're all speaking these different languages, but yet we're going to have difficulty understanding what each person is saying. Even though each person is very knowledgeable, they know what they want to convey, it's going to be a little bit of a barrier on there. So why would you want to have something like BACnet? BACnet was ultimately a solution to a problem. So using my example of language, if you have multiple different people speaking different languages to each other and they have no comprehension of what that other language is, it makes it difficult. Now imagine if you're a building manager, building owner, with all these different devices inside of your building, and you want them to all be able to connect up to either one master controller or talk to each other. Well, if they all talk different languages, that's going to be a problem. And that's what leads to one of the first problems, which is lack of interoperability. Now, there were some companies out there that did try to provide the ability to talk over a network, make it simplified, but it led to closed proprietary protocols. And what that meant is that that protocol is locked to a particular vendor. So in order for you to either implement it, you either had to buy their device and only the devices that they made, or somebody would have to try to work out an arrangement to be able to implement that into their device. And what that could lead to is a lack of scalability, because you may have one vendor that was great at creating a whole bunch of particular devices, we'll say either controllers or maybe thermostats, but it wasn't quite in their wheelhouse to make, say, lighting equipment or VFDs. So what you end up now is that you're trying to expand your building. You're trying to put more into your building, but now you're kind of locked down a little bit because you have a controller that can only talk one language, and you're locked down to what they were able to provide or what was able to talk that language. So what happened back in '87 is that ASHRAE, a committee of ASHRAE, came together and said, look, we need to define something that is open. We need to take care of this whole thing of just being locked into one. We want it to be interoperable, meaning we want to have various different devices, various different vendors be able to come into the network and work. Simplify the integration. Worst thing you can do is possibly try to spend hours and hours integrating your one new device on there and find out that you have to repeat it all over again. We want to make it easy. And buildings are getting larger. Think about your own home. At one point, we used to just have, for your HVAC, you probably just had a thermostat, your heater, and that was it. And now we're putting smart thermostats in there. And if you've got a slightly larger home, you might be looking at putting additional sensors into there so that you can control the temperature in the different areas a little bit better. Well, now you're scaling up and adding more devices. Now imagine that on an even larger building where you're trying to have more control. You want to be able to scale that, have more devices, and be able to get that all onto one communication network. Now, all that scalability doesn't happen all at one time. I don't wake up one day and go, hey, I'm going to put all these sensors here, or maybe put some dampers over there and be done with it. Things are always changing. So as time changes, time moves on, you want to be able to have devices that are currently on the network work with anything else that you're adding onto the network later on. And the idea is to have that backwards compatibility to account for that. And the last objective is be interchangeable. Your devices are going to last for years and years on end. And that's what you want, is for them to run for a long time. But regardless of the device that you have on there, they do have a finite life on there. And you want to have it so that when that device eventually goes, you want to be able to take a new device and put it in its place and replace it without any issues. And that's what we want to do with interchangeable, is take, say, a thermostat that fails, put a new one in there and have it work without a lot of fiddling around to make it work. So how did they accomplish this? Well, back in '87, like I mentioned, they started a committee and said, let's come up with something. Let's start the standards. And it took them nearly 8 years for them to come up with that standard. So in '95, they published in the ANSI ASHRAE standard, specifically 135, they published that standard so that people can go out and look at it and start implementing that. Now, they didn't stop there. They took this and they continue to keep pushing. So ANSI ASHRAE is more of a US type of standard. So they wanted to go international. They knew that there was a lot of benefits beyond just the US. A lot of places can use it. So they pushed, and in '03, they became an ISO standard, meaning it's now a US, or it's more than just a US, it is an international standard, and anyone can use that any place. Now, it still continues to be supported. So it's not something where they created it in '95, they said, we're done. You know what? Let's make it international. Okay, '03, we're now international and then done. We know that the protocol itself and the technology all around it is always evolving. So what that means is that the committee all continues to keep looking at technology, continues to evaluate how to make it relevant as it moves forward. So that 10 years from now, it's still a relevant protocol. 20 years from now, 30 years from now. And the process that they do is an open and balanced process, meaning they do take in feedback from everywhere to be able to do this. They don't just have one person that says, that's what we're doing and that's it. No, it is a committee that evaluates how they should do things and be able to, again, meet some of the criteria that we listed, like the backwards compatibility, interchangeability, scalability that we mentioned. Now, what's great is that in the year since, from 2011 all the way to 2021, the total listings that have, and these are devices that have gone through BTL testing, have increased from 154 to close to 1,200 units. So quick math tells me that we have more than this is more than 6 times what it was 10 years ago. So it is growing. People and vendors are creating devices with BACnet in there because they see the need. Now, if you don't believe me when it comes to just looking at the listings on there, let's look at the adoption rates. When it comes to the adoption rates, from 2012 to 2017, this is when the data was gathered, it went from 50% of new installations, or just under 50% of new installations had BACnet in there. We are now over 60%, at 64%, and it has been growing year over year over year. So in 2021, we're most likely sitting close to 68, 69% of new installations are looking for BACnet so that they can implement that as part of their network. And going back to the previous slides, with all the devices that are out there that are BTL tested, certified, and available, it offers the ability for people to implement that protocol or implement a network that offers a wide variety of devices on there. So how does it work? Well, first off, I kept hammering about interoperable. And this R chart that you see on here, with all the various different vendors, manufacturers that are out there, they make devices that are BACnet compatible. So when it comes to interoperable, you have a choice. You can go to a different vendor, you can find different vendors and find the device that you're looking for. You can say, I want a lighting fixture from here, a thermostat from over here, a VFD from this company, and put it all together. And that also leads to that second portion, not just the vendor's devices, but that interoperable. I mentioned a VFD, a lighting fixture. We also have thermostats, alarm system. All of it could be brought onto one network and communicate and play with each other very well and easily. So it means no interference, no trying to figure out, hey, how do I make this happen or not? Now, to do all of this, we do have to think about how we integrate. So we do want to be able to make the integration easier. So how do we do that? Well, one, we want to simplify that integration. Again, I kept saying we want to make it a little bit easier, but how do we do it? Well, one is we have to create profiles. So there is a definition of what a device is. What does it do? How does what its functionalities are, and what kind of data exchanges on there. And this is a list of all the different device profiles that are out there. So when a vendor like myself creates a device, I'll take a look and go, I'm going to pick one of these profiles and that's what I designed to. And that's what I'm going to test to. Now that I know what my device is going to be, I do need to define what's inside of it. And BACnet uses more of an object-oriented. So everything is more how everything is put together, or data is put together and assembled. So there's more than 50 standard objects, meaning BACnet or ASHRAE has defined a whole bunch of standard objects to say this is how the data looks like, and this is how the data is formatted. Now, they don't just hold vendors to just that specific, or just those standard objects. They do know that vendors have something that could be unique that they want to be able to convey on there. So manufacturers can also create a non-standard objects to be able to provide customers with that information that they might be looking for, the additional stuff that, again, makes their product unique, maybe helps with the integration of the way you're integrating that device onto that controller. So some of the examples of some of these standard objects that are in there could be an analog input. Now, you're not just limited to just one object inside of your device. I'm not just going to say, hey, you can only do analog input. Every device is unique. If I were to pick a VFD, we would have an analog input, analog output, binary inputs and outputs. Now, that's just more of the higher level. These are just the general objects that we have in there. You do need to break it down some more. So each of these objects are going to have properties inside of there. And these are attributes that are assigned to that object. So think of it as the data that's inside of there. And the data is going to be comprised of two pieces. One is the identifier. And what the identifier is just what that particular data represents. So you do need to know the what, but you also want to know most likely the how much or the value. That's the second piece of data that you're going to find inside of there. So one example is we might look at a sensor signal level. So say you have a pressure transducer inside of your duct. Inside of there, you might want to go, okay, hey, I want to know this information. I'm going to read this particular object. I'm going to read a analog output object. I'm now looking down the list and looking for my sensor level. I found it, and that is coming back with a value of 10 milliamps. So that tells me that this is the value that for this sensor, there is 10 milliamps present in there. So now you're breaking down to the information that you're looking for. Now, I've talked about the information itself that's contained inside the device. It's great that I can define an object, I can define the values and what the different properties are that's in there. But for something that's contained inside of there, I need a mechanism to draw that out and pull that. Or maybe even if it's something I can control, take a light, for example, I want to be able to say, hey, I want you to turn on or turn off. So that means I need to have services, actions that I can send to that particular device to make it do something. Whether it's perform an action, like I said, turn on and off for a light, the action could also be give me data. If I'm the controller, I may send information to say, give me some information on there. So for this example, I have a boiler chiller. The controller sends out a question. It says, hey, are you running? That boiler or chiller will respond back with, yes, I am. And now that device knows that, hey, no problem. I've got the data that I'm looking for. Now, granted, my example didn't use the properties that we're talking about, but the general scheme of it is that service, that interaction that we can see going back and forth. Now, scalability. I talked about the smaller home. Hey, I wanted to add a new sensor, but then we looked at a larger size and said, hey, we expanded and we want more. So initially, you might have had this type of configuration on your network. But later on, you find out, hey, I am going to add new VFDs into the system. I'm going to put more boilers and more sensors to help with that. With BACnet, you can scale up. You can add those devices without any problems. So now you can put those onto your network, have it communicating, work on the controller to coordinate all of that. Now, we talked about the data. We talked about the data that's in there, the exchanging of information. We're still now talking more of just, we'll say the virtual of requesting information and sending it out. Now we're taking one more step back, looking at how is that data transmitted, meaning the physical portion of it. Now, there are two main BACnet implementations or physical mediums that are being used right now. The lowest cost, and we'll say the slowest at this moment, is MSTP. And that's more of an RS-485 based network. So its limitations are based off of what you can do on RS-485, but it's also one of the least costly of it. Now, what we're all familiar with is more Ethernet based or BACnet IP, and that particular is going to be based off of your Ethernet. Something that's becoming more and more familiar, but it still has a little bit more cost to implement. But the trade-off is that you can get the information faster. So it really depends on what you're trying to implement and what you're trying to achieve when it comes to how you want to get that information across the network. And again, physically get that information across the network. So now that we've found a way to get all of that information across, both physically, virtually, when it comes to the electronics of it and the data, now that you've got a working network, you're said, this is great. Building's been running for years and years and years, and then all of a sudden, your VFD goes on you. You've been running for 10 years, and the VFD is just had it. And now you're looking, going, okay, well, I need to get a new VFD. But as you're looking, you're finding out that after 10 years, they replaced that VFD with a new generation. Couldn't get that same exact one any longer. So we want to go in and we want to be able to replace that VFD with a new one. Well, when it comes to the backwards compatibility aspect of BACnet, you're able to now go in, replace it with that new device, drop it in, might have a little bit of work, but you'll be able to integrate and get it working in almost no time at all. Now, what if you're in a situation where you've got a device that's in there using a particular vendor and unit goes out and all of a sudden you're now scrambling a little bit and you're trying to figure out, oh my gosh, I need to get something. You call up your distributor, you call up the manufacturer, hey, I need to get this, but they tell you there's no stock, especially in this day and age right now, with everything we're running into. So now you're looking to see who might have something because you need to get this unit back up and running. Well, what's nice is that if you've got a different vendor that you can find, you can also get that replaced in there as well. Drop that in and get it working for you. So now you don't have to worry too much about, oh my gosh, I'm only using vendor A, I got to stick with it. You do have choices when it comes to the interchangeable portion of it. Now, what else should we know about BACnet? Well, what I'm going to do is I'm going to go through a list of misconceptions that come up with BACnet. First one is BACnet is plug and play. It is not plug and play. You do have some work that you need to put into it. So unlike a USB drive that you might plug into your computer and go, hey, no problem, I'm done, I can start using it, you do need to set it up a little bit. So you do need to define it. So we're not going to just plug in and say, hey, you can use this lighting system right away, but you can go in and define on, off, and anything else you might want and get it up and running. BACnet limits the manufacturer's use of innovative control logic, and that couldn't be more false. Every manufacturer, whether it be VFD, whether it be lighting, anyone else, we still have control of how our devices work and what type of innovations we put in there. There's a reason BACnet gives us the ability to create vendor objects. It's so that we can explore new ways and new things to do with that and be able to be more innovative and keep things moving forward on here. It is just, BACnet is just a way to help us define the information that's in there and help people implement and integrate on there. BACnet attempts to standardize how devices are programmed. Again, it doesn't tell us your device has to program this way or that way. A lot of vendors have already defined a way that they want to have it. They've done it for years and years. They're not going to make them change. It's a lot of things to do when you make someone change that way. But they know that if they can have them create that interface to help get that information of their device in the way that they specified, they have made that step forward to make it easier for the user. BACnet defines the hardware platform. It doesn't. If you're implementing BACnet MSTP, all you need, what you need is a serial chip. It doesn't say a specific one. It says that's what you need to implement. If you implement BACnet IP, same thing. It doesn't tell you what processor to use, what MAC-PHY to use, what connector to use. There's a lot of variety out there, and it gives you that capability to choose what works best for you, especially if you're a device manufacturer. And BACnet replaces the need to specify user system or device requirements. No, you need to still define how your system works. BACnet is just that protocol. It's the way to get information from one point to another, how that information is exchanged out there. It's not going to tell you all the details. People are very innovative, whether you're an integrator, whether you are a manufacturer, we are always coming up with new and different ways to integrate things and work with things. Every building is also different. So your specification from one building to another building to someone else's building is going to require something slightly different in terms of its needs, in terms of the devices it needs and how you want to read out that data. So it's not going to limit and prevent people from specifying what they need and what they're looking for. Now, speaking of what to look for, when it comes to BACnet devices, it's highly recommended to look for the BTL mark on there. What this means is that that device has gone through a rigorous amount of testing by the BACnet testing laboratories to ensure that when this device is put onto the network, it has met a criteria so that it is interoperable and it will work with every device. Now, if you want to be able to go out and look for the different devices, there is a portion, there is BACnetlabs.org that will give you a list of all the devices that have passed BACnet interoperability. Now, there's another thing that is a voluntary, it's more of a voluntary type participation amongst vendors, and it's an annual thing where you take your devices and you bring it amongst a bunch of other vendors who want to test their devices with others. Now, the great thing about PlugFest is that when it comes to this type of environment, it's an annual one, so you do get a chance to do this every year. It's vendor neutral and it's safe, meaning the information in there is confidential. Everyone signs off and says, hey, we're not going to talk about all these other devices that we saw in there. And it is voluntary. So it is worth asking the vendors whether or not they did it. But what's great about PlugFest is that it gives you a chance to be able to interface with devices you wouldn't have a chance to really do in your lab on a normal basis. On any PlugFest that I've seen, you can have over 50 to close to 100 participants there, all with different devices. And those devices give you that chance to be able to see how you play with them ultimately on the network. And the reason that's valuable is that, like many things, a standard with an open standard, sometimes there's room for interpretation in there. And how one person interprets information versus somebody else could be different. And sometimes could be different enough where an environment like this will help you find that conflict. But what's also great about it is that also provides you an environment to help you work through that conflict and be able to determine what is a good way. And also be able to talk to the people at BACnet to help define that standard and maybe even refine that standard going forward so that we can avoid those mistakes moving forward on there. So what have we learned today? First, hopefully you know what the purpose of the BACnet protocol is, why was it created, what it's trying to do, the benefits of the BACnet protocol. What are you going to gain from using BACnet or from using it on your facility? The uses of the BACnet protocol. So how do they use it? Where? All of those. Now, final thing I will say when it comes to BACnet and when it comes to all the devices that are out there, BACnet really offers the backbone of information exchange. And that is going to be big when it comes to coordinating a system, especially one for energy efficiency and coordination. So be able to take advantage of such a great network and be able to get the information from one point to another is tremendous, in my opinion. Now, if you're looking for more information, I realize that stopping by the BACnet International booth may not be an option, but you can also go to the BACnetinstitute.org. You can register for an account over there. It is free. There is a bunch of educational sessions that are in there. They are all free, and it'll give you a lot more information. Some of the information that I presented today and more in-depth information for you to find out more about BACnet and the protocol itself. Or if you want to find out more about BACnet International, you can always go to BACnetinternational.org and learn about what that trade organization can do for you. Thank you and have a good day.